We're going to go ahead and continue with section 6.5 and complete the chapter. In this video, you're going to see powers of complex numbers and then the nth roots of complex numbers. And we have a couple formulas that I'm going to introduce to you. But first of all, let's look at what happens when we are multiplying complex numbers by themselves. So this is a complex number right here, and it's in trig form. So what we're going to do is multiply it by itself. So it's r squared and then cosine theta plus sine theta squared. So taking that times itself is what we're going to get. Now we're going to have to FOIL this out. I've got r squared, and then if I FOIL this, I'm going to get cosine squared plus the middle term. See, there's an I here. I forgot my I. There's a middle term of 2I cosine theta sine theta. And then the last term would be plus I squared sine theta. Well, plus I squared would be really minus then sine theta squared. All right, so that's what happens when we FOIL. Again, I FOILed the binomial here, so you square the first, you double the product of the middle term, and then square the second, which becomes minus because of the I squared. Now, what we've got here is we've got some formulas in here that represent the double angle. If I put together, my cosine squared minus sine squared, that is simply the double angle for cosine. So that's really cosine of 2 theta plus, and if I put my expression here, the 2, the cosine, and the sine is the double angle for sine. So it's I sine of 2 theta. All right, so you can see the results here. I have my original z. If I square the z, then the r becomes a power of 2, and the angles become the double angle. Well, what we can start to do is we can start making some assumptions here. So if I'm going to do a cube, then it's going to be r to the third, and you would suppose that the angles would then become not double angles, but triple angles. So I sine of 3 theta. And so what that leads us to believe is then, well, what happens then as z goes to the nth power? So here's your formula for the exponent. So you've got z to the nth power equals r to the nth cosine of n theta plus I sine of n theta. So you're going to insert the n's here, whatever your exponent is. All right, let's go ahead and try one. A couple things that we have to know. You have to find the r value. What does r equal? And what does theta equal? And in what quadrant? Because that obviously is going to control the angle. All right, here we go. Let's find our r value. So r would equal the square root of -1 squared plus the square root of 3 squared. This is going to give us the square root of 4. R is equal to 2. Okay, and now let's find theta. So theta would be inverse tangent of root 3 over -1. This gives us a reference angle here of, this would give us -60 degrees. Well, we need to put that into see our complex number here is in quadrant 2 because it's -1 and then root 3. So we need to have that angle to be 2/3 pi. So from here to here, 2/3 pi. So this is our theta that we're going to use. All right, now we're ready to substitute into our formula. So we've got our z to the 12th power would equal, we do r to the 12th, so 2 to the 12th, times cosine of 12 times 2/3 pi, plus I times sine of 12 times 2/3 pi. All right, so we've got z to the 12th equals 2 to the 12th is 4,096. And this would be cosine of 8 pi plus I sine of 8 pi. Well, 8 pi is the same as 0 pi. So we've got 4,096 times cosine of 8 pi is 1, sine of 8 pi is 0. So my answer is 4,096. This is the complex number raised to the 12th power. That's what that is equal to. And that's how your formula works. All right, the next thing that we're going to do is find nth roots. Well, this is how we found nth roots in the past. We have to find all 4 solutions. All 4 solutions, one way is by factoring. So I could take x to the 4th, subtract the 1, set it equal to 0, factor the difference of squares. It is x squared plus 1 and x squared minus 1. So this gives me solutions of plus and minus I, and the other one would give me solutions of plus and minus 1. So those are all 4 of them. The problem with that is if I'm giving you a complex number that we're not able to factor. So there's a formula that we're going to use. Here's the formula for finding the nth roots of a complex number. Z to the 1 nth, this is the same thing here, writing it in an nth root of z. You find it by taking the nth root of r, so again we're going to have to find out what does the r equal. And then cosine of theta plus 2 pi k over n. Now k is going to be the numbers, k will be the numbers starting at 0 going all the way up to n minus 1. So whatever your nth root is, so if it's the 3rd root, then we're going to go 0, 1, 2. If it's the 5th root, we're going to go 0, 1, 2, 3, 4. So all the way to 1 less than the nth root. But anyway, you take cosine of the angle here and divide by the n, and then I sine the angles on top divided by n. So we'll have to also find theta and make sure we're in the right quadrant. We'll have to find the quadrant and what your n is equal to. So those are the important parts to this formula. Make sure that you pause the video and you write your formula down. We're going to go ahead and find now the roots. So find the nth root of a real number using the formula. Well, the first thing that we want to do is put this number into complex form. So this is x to the 4th equals 1 plus 0i. On this page here, let's go ahead and find our r value. So r would equal the square root of 1 squared plus 0 squared. So r is just 1. And theta. Theta would be inverse tangent of 0 over 1. So when is tangent equal to 0? It's at pi over 2 and 3/2 pi, but this complex number is located right here. This is my complex number. Excuse me, the inverse tangent, this is when does tangent equal 0, not undefined. So it's either at 0 or pi or 2 pi. So I can actually use my theta just to be 0. And my n value, I'm finding the 4th root of, so n is 4. So let's go ahead and transfer this information over to the other side. Here's what I've got. I've got my theta is 0 degrees, or 0 radians. We can use radians. My r is equal to 1, and n is equal to 4. So this concludes that my k's, are going to be 0, 1, 2, and 3. So what I have to do is I have to do this problem 4 times when k is 0, 1, 2, and 3. So let's first do it when k is equal to 0. I'm going to substitute. I've got my nth root, so the 4th root of 1 times cosine of, and you do your angles. So it's cosine of the angle 0, theta plus 2 pi times k. And this time my k is 0. All over the n, which is 4, plus I sine 0 plus 2 pi. The k value is 0, so times 0, all over 4. And we are going to evaluate and simplify this. So the 4th root of 1 is 1 times, you have cosine of. Well, cosine on top we would have 0 over 4, so cosine of 0, plus I sine of 0. So this is going to give us our first solution. Our first solution would be 1 times cosine of 0 is 1, sine of 0 is 0. So this first answer is equal to 1. Now what we do is we repeat this process for when k is equal to 1. So we'd repeat all of this again. Okay, so this is my first solution. Here's going to be my second solution. We do the 4th root of 1 cosine of 0 degrees plus 2 pi times 1 over 4 plus I sine of 0 degrees plus 2 pi times 1 over 4. So this evaluates to, we have the 4th root of 1, which is 1, times, here we've got cosine of, if I do 0 plus 2 pi times 1 divided by 4, that's 2 pi divided by 4, or cosine of pi over 2, plus I sine, and again, it's going to be the same angle, so pi over 2. We evaluate this, it's just 1 times the result. So the result is cosine of pi over 2 is 0, plus sine of pi over 2 is 1. So the answer is I. Second answer. So what you're going to do is you would repeat this and find it, well, when is k equal to 2? And what's the answer when k is equal to 3? Go ahead and pause the video and complete that, filling in your formula. You fill in your angle is 0. See, this 0 that I keep putting into my equation, the 0 right here is my angle. This is my angle I'm starting with. It just happens to be for this problem, that's what we're going to use. All right, go ahead and pause and finish out. You should get for your last 2 answers the other solutions that we have for the 4th root, and that would be, so for when k is equal to 3, we get -1, and when k is equal to 4, we get -I. So those are all 4 solutions. All right, let's take a look at another problem. I'll get it set up for you, but I'll let you solve it. Here's what we've got. We've got our complex number. Z is -2 plus 2i, and I want to find the cube root of it. We need to figure out the r value, so we're going to do square root of -2 squared plus 2 squared. So this r equals the square root of 8. Okay. All right, now what we're going to do is find theta. So our theta would equal inverse tangent of 2 over -2. So this gives us, we got to find that angle in quadrant 3 here. So when's tangent -1 in quadrant 3? So that is at 135 degrees. 135 degrees, or what you can use is you can use 3/4 pi. It doesn't matter if you use degrees or radians, so I'm going to show you in this problem that we're going to use degrees. And then my my n is equal to 3, so I'm going to do k values of 0, 1, and 2. It's always one less. So we're going to use our r is equal to the root of 8. Our theta is equal to 135 degrees. And the k's going from 0, 1 to 2, and n is equal to 3. So we're going to substitute. Now we got to do the z is going to equal. We've got the third root of the square root of 8. Okay, that really is just the 8 to the, see, this is equal to 8 to the 1/2 to the 1/3, so 8 to the 1/6. This, we'll use our calculator to evaluate that. Times, we've got cosine of my angle, so it's 135 plus 2 pi, or 360, times 0, all over 3, plus I sine, this would be 135 plus 360, you put the first k in, times 0, all over 3, and we're going to evaluate this. We've got the 8th to the 1/6 power times cosine of, so we're going to do cosine of 135 plus 0 divided by 3. So that's cosine of 45 degrees plus I sine of 45 degrees. So this is all when k is equal to 0. This is my first solution. So we got 8 to the 1/6 power times, well, cosine of 45 degrees is root 2 over 2 plus I sine of 45 degrees is root 2 over 2, and multiply. Now you can just use your calculator here, but when you go to distribute here, you're going to get 1 plus I. So this means this is one of my solutions, 1 plus I. All right, I'll start to set up the next one, but I'll let you finish. So now we're looking at when k is equal to 1. So we've got, again, 8 to the 1/6 power, cosine of 135 plus 360 times 1 all over 3 plus I sine 135 plus 360 times 1 all over 3. So as you go to evaluate that, you're going to figure out your angle and divide by 3, and then find the cosine and distribute the 8 to the 1/6. Go ahead and pause the video and then also find when k is equal to 2, and that'll give you the rest of your solutions. Your solutions will be negative 1.366 plus 0.366I, and for the last one, 0.366 minus 1.366I. So those are the three solutions, along with the 1 plus I from when k was equal to 0. All right, that concludes this Chapter 6, Section 5.